Hello everybody, how are you?
Morning. Hi, Mister.
Hi, Mister.
Are you listening?
Yes.
Okay, let us continue our discussion. Before we start to the discussion for today, let us revise what we discussed on our previous Zoom discussions. Okay. Okay. First, the topic that we discussed on the Zoom discussion is square numbers. Square numbers. Before we define square numbers, last time we defined powers as an introduction. Powers. We define powers as an expression written in the form like this, and the number written under this position is called base, and the number written under this position is called exponent. So when we try to read this expression, we can read as a to the power of n and a raised to n, or the n's power of a. We can read in three different ways. So under this topic, let me add some properties of power. Let us take a is an element of any rational number. Then a the power of 1 is a. That means the power, any number power of 1, the result will be the base itself. And the second, a is a power of 0, 4 is equal to, it is 0, but for this case, the base must be different from 0. So if the base is different from 0, any number the power of 0 is 0. And the third property of power, basic power, 0 the power of 0, which is equal to undefined. In mathematics, there is no expression 0 the power of 0. So under the introduction part of powers, you can add these three properties. After that, we define a square numbers. We define square numbers in three different ways, if you remember. A square number can be defined as a number which can be written as a product of two same factors. We can define like this, or it is a power with exponent 2, or it is a rational number that can be obtained when we multiply a given rational number by itself. We can define with these three ways. Let's say a is an element of a rational number, then a times a is equal to a squared. So this is a square number. So when we read this expression, we can read in three ways. You can say a squared, or the square of a, or a to the power of 2. Okay, after we define a square numbers, we also consider a special name for square numbers, that is perfect squares. Perfect squares. Perfect square is nothing but is just a special name given for those square numbers. Any number written as a power with exponent considered as perfect squares. So if, let's say, x is an element of rational number, and if we say this x is a perfect square, it must be written as a product of to same factor or as a power with exponent to like this one. If we say x is a perfect square, so x can be expressed as n times n or n square. Here n also are element of rational number. So to say a given rational number as a perfect square, to consider as a perfect square, it can be expressed as a product of two same factors or as a power with exponent 2. So we did this discussion last time. Lastly, properties of square numbers. Last time, the last discussion on the program is about properties of square numbers. We consider 3 basic properties of square numbers or perfect squares. And I told you that you can add by your own. So there are so many different properties of square numbers. The first property that we consider, square numbers are non-negative. Square numbers are non-negative. So when we take the square of any rational number, the value is positive or 0, non-negative. The second property, if we consider let A and B is an element of rational number, any rational number, then by property A times B square means A square times B square. And also A over B square means A square over B square. And the third property, the units place of a square number index with 0 or 1 or 5 or 6 or 5 or 6 or 9. Square numbers index with their unit digits with these numbers. So you can also add by your own. Now let us go to our discussion for today. Now let me give you an introduction before we define what by mean a square roots. Let us take a, let's an irrational number a, and let us square this number. So the square, when we square this rational number, we get a square. Let's say which is equal to, let us go through the reverse of this process. Now let us take this a square and let us pass through the process of square root. Square root. So when we square root the result a square, we get also again b or a. Okay, so if we take an irrational number and if you square it, we will get a square. And again, when we take a square and under the process of square root, we get also again a. So to define a square root, when we define a square root for any rational number, for any rational number, that satisfies the condition a square is equal to b, then we can say b is the square root of a. So when we express this expression, so when we write in symbolical way, So we can say the square root of b is a. So under this expression, you can give a special name for this symbol. You can give a special name for this number that is written under this symbol. So this symbol is called radical sign. And the number written under the radical sign is called radicand. Radicand. So for any expression for two rational number a and b that satisfies this condition, a square is equal to b. So when this condition is satisfied, we can say the square root of b is equal to a. And when any number expressed in this way, you name this symbol as a radical sign, and the number written under the radical sign is called radicand. So let us consider examples. Okay. So once we define what by mean a square root, to calculate the square root of a numbers, if they are perfect square or square numbers, that is a very simple job. So to calculate the square root of the given numbers, a, we are given a number 4, so we are asked to find the square root of a, the square root of 4. So 4 can be written as 2 times 2. So as we said before, if the expression above this expression is satisfied if the number written as a square is equal to b, so the square root of b is a. So with this definition, so the square root of 4 means it is equal to 2 because since 2 square is equal to 4. If this expression is satisfied, so we can say 2 is the square root of 4. So like this wise, we can calculate the square root of any perfect square numbers. B, the square root of 16. So the square root of 16 can be written as the square root of 4 times 4. So which is equal to 4 because 4 square is equal to 16. Again, the square root of 1 over 25 is equal to, can be written as the square root of 1 over 5 times 1 over 5, which is equal to 1 over 5. So since or because 1 over 5 square is equal to 1 over 25. So simply you can calculate the square root of perfect square numbers like this one. Is that clear?
Yes.
Yes.
Do you understand?
Yes,
By
1
what mean
over
square root?
24.
1 over
1 over 5 ነው መሰለኝ የሚመጣው።
ምን አልክ? እስቲ በደንብ ተናገር ጥያቄን። Okay, let us continue. Let us add one more example. Okay, when you get numbers that are larger than smaller numbers as a perfect form, as a perfect square form, we can use a factor 3 to calculate the square root of the given numbers. So let us do this example. If you don't know how to write as a product of the same factor for the given radicand, simply you can use a factor 3 like this one. When you divide this by 2, it is 100. It is by 2, 100. It is by 2, 50. It is by 2, 25, and by 5, 5. After that, we group the factors into two equal parts. There are two factors and five factors. So when you group into two identical groups, you can write 2 times 5, one group. Again, 2 times 5, another group. So 2 times 2 is 4, 4 times 5 is 20. So 400 means 20 times 20. So therefore, the square root of 400 is equal to the square root of 20 times 20. So when we out 400 out of the square root, it will be 20. So when we get larger numbers, we can calculate like this. When we ask to calculate the square root of the given numbers. Let me give you an exercise.
Mr.
አይታያችሁ? Okay, let me give you some time and try these questions.
ستوري መጨረሻ ይነበብ
The square root of 172 minus 3. This is minus. Okay, let us do together. What will be the answer for A, the square root of 0?
0.
Yes,
Zero.
it is 0.
0.
Yeah, 0 is a perfect square number. It can be written as 0 times 0 or 0 squared. So the square root of 0 is 0. What about the second one?
Minus 1 over
Negative 1
9.
over
minus
9.
1 over 9
Minus 1 over 9. There is a minus sign out of the square root. Remember this. So when we take alone the square root of 181, it is 1 over 9 because 1 over 81 can be written as 1 over 9 times 1 over 9 or 1 over 9 squared. There is a minus sign, so totally when we put the answer minus 1 over 9. And the third one, C,
2 over
2
7.
over 7
2 over 7.
2 over 7 exactly. And the D, 324 over 625.
18 over 25
18 over 25.
18 over 25. And E,
12.
minus 12
Minus
no 12
negative 12.
12
think over it, E,
positive 12 miss
no,
Negative 12.
remember the definition,
No answer.
Negative 12.
no answer, it is undefined. The radical cannot be a negative number for the case of square root, so which is undefined or no answer. Undefined, or you can say there is no solution for this case, so which is undefined expression. Okay, F
1 over 64
1 over
1 over
64.
64.
1 over 64.
You are right. 1 over 64. 1 over 64 square means 1 over 64 times 1 over 64. So when we take out under the square root, it will be 1 over 64. And the last one,
1 over 64.
13
13 square.
not 13 square,
13 which
13, yes. 172 minus 3 is, it's 169. So 169 can be written as 13 times 13 or 13 square. So the answer will be 13. So we can define a square root like this one. To finalize, let me revise what we did
Mr.
today. Yes,
Mr. What is wrong with E?
E.
Yeah.
I told you, the radicand cannot be negative when we consider a square root. The reason why? Because when any two rational number A and B, if A squared is equal to B, we say B is the square root of A. Is that not? So the radicand cannot be negative number. Always it is positive or 0. That's why we say we answered as undefined or no solution. Do you get my point?
Yes, yes, Mr.
Yes.
So when for any two rational number A and B, a square is equal to b, we say b is the square root of a, and we write this in symbolic way like this one. So when we write any expression like this expression, so this is a radical sign and this is a radicand. And remember, the radicand cannot take any negative value. Always it is positive or 0. Is that clear?
Yes.
Yes.
Next time we'll continue. For today it's enough. Bye.
Bye.